Circles. Terms related to circle. Circle. Collection of all points at constant distances from a fixed point in a plane is called a circle. Center. The fixed point from which all other points are equidistant is called center. The point O in the circle is center. Radius. The fixed distance of any point on the circle from the center is called radius. Distance OP is radius. Chord. The straight line joining any two points on the circle is called chord. Line AB is a chord. Diameter. The chord passing through the center is called diameter. Diameter is twice the radius and is the longest chord in the circle. Segment. Chord divides the circle in two parts called as segments. Sector. The region enclosed by two radii is called sector. Arc. The connected part of the circumference is called arc. Three possibilities of line and circle. No common points. If there is no common point between the line and the circle, then the line is called non-intersecting line with respect to circle. For example, PQ is non-intersecting line. Two common points. When a line passes through a circle, then it creates two intersecting points AB with the circle. In this case, line is called as secant of the circle. For example, PQ is secant. Only one common point. When there is only one common point, that is, the line touches the circle at single point A, then the line is called as tangent to the circle. For example, in a pulley arrangement, the rope is like a tangent to the circle, that is, the pulley. Tangent to the circle. A tangent is a line that touches the circle at one point. Activity 1. Take a circular wire and a straight wire AB. Attach AB to circular wire so that it can rotate at the point of contact, that is P. Place the arrangement on the table and rotate the wire so as to get different positions of the wire with respect to circular wire. It is observed that as we rotate the straight wire, it intersects the circle at 2 points. On rotating further, a condition arrives when the straight line touches only once to the circle. Thus, a circle has only one tangent at any point. The two touching points of the straight line coincides. Thus, the length of the chord becomes 0. Activity 2. Draw a circle on a paper and a secant PQ on a circle, as shown in figure. On both sides of the secant, draw parallel secants. It is observed that the length of chord goes on decreasing and the two intersecting points comes closer and closer. At a point, the length of the chord becomes 0 at both sides of the secant. indicating that the circle always has one tangent at a point on the circle. The common point of the tangent and the circle is known as point of contact. Example of a tangent. When a bicycle moves along the ground, then the line on which wheel is moving is the tangent for the circular wheel. Theorem. The tangent at any point of the circle is perpendicular to the radius through the point of contact. Proof. Consider a circle with center O and tangent xy at point P. We have to prove that OP is perpendicular to xy. Construction. Take a point Q on xy other than P and join OQ. Proof. OP is radius and OQ is somewhat bigger than radius. Thus, we can say that OQ is greater than OP. It is true for every point on xy except point P. Hence, we can say that distance OP is shortest distance. But the shortest distance is only possible if the line is perpendicular. Thus, OP is perpendicular to xy. Normal to the circle at the perpendicular line passing through the radius is often termed as normal to the circle at a point. Number of tangents from a point on a circle. To find how many tangents could be drawn from a point, we need to consider three cases, as the point may be inside the circle, on the circle, or outside the circle. Case 1. Point inside the circle. Consider a point P inside a circle. Now, if we try to draw tangent to the circle through this point, then we can observe that tangent could not be formed from this point, as each line drawn through this point intersects the circle at 2 points on the circle. Thus, we cannot draw tangent to the circle from a point inside the circle. Case 2. Point on the circle. A point on the circle allows one tangent to pass through it. Thus, we can say that there is one and only one tangent can be drawn through a point on the circle. Case 3. Point outside the circle. Consider the third case in which point is outside the circle. Now, we can draw two tangents passing through this point, touching the circle at point T1 and T2. Thus, we can say that we can draw exactly two tangents from the point outside the circle. Length of tangent. Length of tangent is the distance from the external point from the circle to the point of contact. Distance PT1 or PT2 is the length of the tangent. Tangents from external points are equal. Theorem. The lengths of tangents drawn from the same external point to the circle are equal. Given. Consider a circle with center D and tangents AB and AC at point B and C respectively. To prove, AB is equal to AC. Construction. Join DC, DB and DA. Proof 1. By joining DC and DB, we get two angles, angle DBA and angle DCA. Since these are the angle made by tangents to the radii, hence these are right angles, that is 90-degree angles. So now we have two triangles, triangle DBA and triangle DCA, which has DB equal to DC equal to radius of circle. DA is common side of both triangles. So triangle DBA is congruent to triangle DCA. Hence AB is equal to AC by CPCT. Hence it is proved that the tangent from the same external point to a circle are equal. Proof 2. This theorem can also be proved by using Pythagoras theorem as follows. Since the two angles, angle DBA and angle DCA are perpendicular, hence by using Pythagoras theorem we have AD square is equal to AB square plus BD square for triangle DBA. Similarly, AD square is equal to AC square plus CD square for triangle DCA. Thus, we get AB square plus BD square is equal to AC square plus CD square. But as BD is equal to CD, hence AB square is equal to AC square. Therefore, AB is equal to AC. Hence, it is proved.